The slightest glitch in services or access to data can cause screams that the sky is falling. Aside from user expectations, there are also high levels of criticality associated with service delivery, such as in the medical field and others alike, where time is of the essence. For most companies, unexpected downtime can result in a significant monetary loss, even if just for a short period of time. Resiliency in the network is an important piece of the puzzle when designing for high availability. One of the key principles instilled by Extreme's Fabric Connect technology is lightning-fast convergence times. Joining us today is cybersecurity expert and distinguished principal engineer at Extreme Networks, Ed Kohler, to showcase the proof of resiliency in the fabric and our management tool, XMC. Okay, so what are we looking at? Why do we have the video up, and how are we going to showcase the resiliency in the fabric?
Okay, well, you'll notice that there's also a tool associated with the video as well. It's kind of doing a low-level diagnostic.
Yeah.
And the reason why we do this is because video is really a fairly demanding type of application.
Yeah.
Okay, if you lose a few frames of video,
you
see it in the picture. So what we're going to do is we're going to kind of demonstrate how we can fail over the network in a seamless fashion without affecting the video delivery. Now, we're running the ping diagnostic because we do want to show that there are some minor response time changes that we may see, maybe a drop of a ping, but you know, the point is that the video will remain intact. So we do show that a network state does occur and a change occurs.
Got it.
And this is important. So right now we're looking at the normalized behavior. We see video traveling between 10.9.3.19 on the lower left-hand portion of the screen, and that is traveling over to 10.9.4.16. So our transmitter is over here, our receiver is down here, and this is the actual path that the video is taking across the actual fabric infrastructure at this time.
Okay, so we're looking at a real-time topology view and the actual path that it's currently taking.
That is correct. This is not a device topology view. This is actually looking at the fabric in a real-time fashion. So this is actually showing us how these backbone VLAN IDs are behaving across the network.
So you're telling me that if we disable one of these links here, that I'm not going to see or may not see much of a blimp in the video?
That's the idea.
Okay.
So what we're going to do is we're going to go up and we're going to shut down port 2.3 on 10.9.4.16 because that's where our transmitter is, okay? Now that's actually going to affect the actual service path that we're using, obviously, because that port is no longer available.
Right.
So this is going to emulate a switch failure or a link failure or something of that nature, okay? So what I'm going to do is I'm going to go over to our devices view, and I'm just going to highlight the switch that is in question here, and we're going to go in and we're going to execute a CLI command. Now I've kind of written some nice little scripts here.
Right.
The first one is just the shut command. So we're going to go in and we're going to say that we want to shut down interface number 2.3. Okay, so that's, you know, slot 2, port number 3. So we're actually going to execute that. And as you can see by watching the video content, it's seamless. You really can't see it. The only thing you might see is a little bit of a blip on the diagnostic tool.
I actually didn't even see, okay, I think I did see it, but I might have blinked.
Yeah.
So
it's very fast.
But
200 milliseconds or under, okay? And this is a fairly simple topology, so we're probably well on the order of under 100 milliseconds. This is the old view, okay? Remember, this was the previous path that we were taking. What we did was we shut down port number 2.3. So at this point in time, what I want to do is I want to highlight these nodes again, and this time I want to query it and say, what is the alternate path behavior that we're taking now? So as you can see, we failed over to the lower path. We're now going through a completely separate set of switches, and this shows the resiliency of the fabric on a real-time basis. As always, some of the toughest things are when a network recovers back to the original path. We all know that that tends to be very problematic in RIP and OSPF type networks. You know, they tend to handle outages a lot better than they do recovery. So what we're going to illustrate now is a graceful recovery, basically. We're going to go back into the device and we're going to run, basically, a script that will re-enable that port. What we're just going to do is pick up that no shut command. And as you can see, this actually shows us the commands that we're going to run. We're going to go to interface 2.3 and we're going to execute the no shut command. As you can see, we start the script, we get a response, and then it comes back and tells us that it is now completed. Okay? So now we can go back in and we can view the results that indeed we have run the no shut command. Now we can go back to our topology diagram. Now remember, this is the redundant path that we're seeing here. Now we've gone back in and we've re-enabled that port. So now we want to see exactly what happened to that path behavior. As you can see, we fell back to the original path. So I think you can see that this kind of shows the benefits of the distributed control plane,
yes,
the benefits of the distributed data plane architecture, and the ability for us to have the knowledge within the fabric that we've talked about earlier,
right,
to basically heal the fabric seamlessly.
Right, and that's a great point that you touched on. It's great to visually see that no stream was disrupted based on the resiliency, but really the magic behind that is the distributed control plane, the ISIS configuration that's enabled on every node in the fabric, right?
Absolutely.
Very cool. Thank you so much, Ed, and great to visually see how resilient the fabric can be.
Thank you for having me, Erica. Always a pleasure.